Okay, let's get started on part 2. So the plan here for part 2 is to lay out some of the basic nim code. Then we're going to bring in some of the defined constants that zpipe.c uses. And then we'll mock out the main function in nim, and then we'll make sure that we can compile and run our nim code and get it initially working. So to do that, let's edit zpipe.c. So this is what we're working from, and I'm going to make a new file called nzpipe.nim, and this will be our nim code. Now, we've already gone through the zpipe C code a bit, so let's have a look. And basically what we want to initially do is implement the main function just to set something up that nim will be able to do. So to do that, we will basically just write some code. Nim treats everything in the file as just the main function if it's not put in any functions or anything. So we'll make a var called return of type cint. So we'll be using this cint type rather than the int type, as that makes sure that the integer size, if it's an int32 or something, matches the C code. Now, in the zpipe side, you can see that they force the standard in, standard out pipes into binary mode, but we don't need to do this in the nim side. With our functions to read from them, we can just read in binary mode by default. Then they start looking at the arguments in the zpipe side. So to capture the arguments in nim, we will be using I think it's called get command args. Let's have a look. Get command line. Here we go. Command line params. A convenience proc which turns the command line parameters. This returns only the parameters. If you want to get the application executable file name, called get app file name. So this is the function we want to use, and it will basically return us a sequence of strings with the arguments. So let's say here args equals, and we'll say here let args equals command line params. So the first thing they're doing is just checking if the argc, which is the argument parameters, is of length 1. That's the arg count in C. So we can do the equivalent by checking the length of the command line params, but the argc will always include the executable name in the C side. So in the C side, 1 indicates that there is no extra arguments, while ours won't include that. So we can say if args.len is equal to 0, then we want to execute the deflate command. Now, what I'm going to do is I'm going to start putting in some debug flags here. So let's make a little const section, and we'll say debug equals true. So I can put things behind this debug flag, and that will allow us to turn them off at the end. So if debug, and then let's say it's standard error dot write line, and we can write out running compression, because this will match what the C side is doing. They're running the deflate command, and that is to compress the file, as in deflate it. And then we'll just put in just a to-do here. We haven't actually implemented the deflate command yet, but we'll do that soon. Then, actually, I might just copy in here, do compression if no arguments. So I'll just put in their comments to match what they're doing, so that we can sort of trace it nice and easily. Do decompression if -d is specified. So elif args.length is equal to 1 and args, the first argument, is equal to dash d, then we want to do decompression. And I will just put in basically the exact same code here, running decompression. And then finally on the C side, they just say any other circumstance, report the usage. So we'll do the same, else, and they put it onto standard error. So let's say standard error.writeLine, zpipe usage, and we're going to call ours nzpipe. So let's say nzpipe usage there, and then we'll quit with 1 as the exit code, and that's all we'll do. Now let's just make sure this compiles and is functional. So nim c, short for compile, nzpipe.nim. Okay, so we undeclared identify command line params. Now I believe this comes from the OS library. So let's import OS and try again. Yep, okay, so that worked. And it seems to have successfully compiled it. So let's do dash R, nzpipe, and, just dash R, and that will run the code after we're done compiling it. Arguments can only be given if the dash R is selected. Oh, I see. So it's compile dash R nzpipe.nim. And you can see that if we pass it without any flags, it'll say running compression. If we pass it dash D, running decompression. That's just the last line here. The rest is the compiler executing. And if we run it with dash H, it will report the usage, nzpipe usage, and then execution of an external program failed. So it's telling us that the exit code was not considered successful, but it did print out the usage for us. So that's good. Okay. So that's a good first step. Next, we've got to move on to bringing in the hashtag defines that zpipe uses, and I'll show you what I mean for those. So when I say these hashtag defines, what I mean is on the zpipe side, you'll see that they refer to a lot of these z underscore default compression and z underscore OK. So what are these? These are actually brought in by the zpipe library when it imports the zlib.h header file. So if we look at the top of the zpipe file here, you can see that they include zlib.header. So let's have a quick look at that file. So if I'll open a new tab here, and it will be in user/include zlib.h. So this is the zlib header file, and this is actually a great reference for the zlib library. It tells you a lot about how it works, as well as how to use it. And you can see that they're including zconf.h as well as a bit of other stuff. But then they have all these different defines in their code. So zlib version, version number, major minor revision, etc. And libraries, programs that import this library can use these defines to determine things and check stuff. So if I keep going down, they've got a whole block here of different constants that they use. So these are the constants. So they've got the different flush settings. They've got the return codes for the compression functions as well as compression levels. So, and this is where this ZOK is coming from, and Z default compression, etc. Now they don't have in Nim. There's no way to import these defines because these defines are not actually variables in C. They are going to be managed by the C preprocessor, and then is going to replace the values in the code with the actual values that have been defined here. So what we can do on the Nim side is instead just copy these values as is into the code and then make them consts. And consts are in Nim are going to be processed as they are processed at compile time and replaced, so they have the sort of equivalent functionality. Unfortunately, there doesn't seem to be a way to import these names directly from the C side, which means that if your library upgrades and they change some of their defined constants, you may need to update the nim side, which seems problematic, but this is the best way I could find to do it. So we'll put in the, I'll call these zlib.h constants, and we'll just chuck that as a comment, and then we can turn these into nim constants. So let's just move these comments around. Get rid of that. For some reason these names are changed after the oops, we want that as well. These comments, refer to the block before the comment, which is a bit strange, but okay. And now I'll just do a bit of regular expression replacing to replace all these values with their with the correct syntax. So I should be able to do something like substitute hashtag define space with just a double space, and that will set all of those. And then I should be able to also now select all these blocks and do another substitute, and what we'll say is we'll do a capture group z underscore backslash word character star, and then backslash space star, so we'll capture all the way up to there, and we'll replace that with backslash 1 equals space. Cool, so we should have now a bunch of constants that all match. So z no flush, z partial flush, and these will all refer to the values that we want to refer to here. And we can now use these throughout our code. Okay, so carrying on. Now we want to start actually implementing the code that the zpipe.c provides. So let's have a look at our first mode that we'll run in. So what we're going to do here, this is on the C side. When it's in compression mode, it takes the standard in and standard out and the z default compression, and it passes them all to this deflate function, then captures the return code, checks if the return code is okay, matches the okay, and if not, it will then call this z error function to process the error, and then it returns the return code. So let's do something similar on our nim side. So this is our compression version. So we'll say return equals def. We'll pass in the standard in, standard out, and a z default compression, and then for now let's just do that. We won't process any of the return codes. Actually, I'll just chuck a to do here just to keep that in mind that we've got more to do there, and then we'll quit with the return code. So that's all good. Now let's actually start making that function. So we'll define up here proc ret, and now what we want to pass in is standard in, standard out, and the default compression. So let's have a look at what those are in the C side. So if we go all the way up to the deflate function in the C side, you can see those are files. In the nim side they also will be files, so we'll say source is going to be a file, dest is going to be a file, and level is going to be a cint. Now this returns a cint, as you can see, and then we've got the code. So we have some vars here. So we'll say cint, ret flush will be cints, etc. Then we've got these different unsigned, have, unsigned char, and also this z-stream type. So this is something new. We'll have to explore that. But for now, let's just say if debug standard error dot write line started running decompress. Sorry, this will be def function. Okay, and let's just also compile our code at this stage and make sure we haven't broken anything yet. So we'll run that just as is. So redefinition of ret previous declaration here. So we've got an error that's on line 42, 36, 42, right? So it doesn't like us having inside the proc the return and the flush. Oh, sorry, the ret be redefined up there. That shouldn't be a problem, but doesn't seem to like it for some reason. Sorry. It actually is complaining that I called the proc ret when I actually meant def, as in deflate. So let's just try that again. Cool. So running compression, started running the def function. That looks good. And it is complaining also to us that we declared a whole bunch of these constant variables but don't use them. That's fine. We don't use them yet. We may not use all of them, but for now, the expectation is most won't be used. Okay, so that's a good stopping point, I think, for part 2. So we've started to mock up the code, but we haven't actually got through the process yet of actually executing any of the code, the actual logic around compression and decompression. But we are making steps in the right direction. So in part 3, we'll jump into how we actually implement this deflate function in the nim side. So I will see you all in the part 3. If you have any comments, feel free to chuck them in the comments. Otherwise, yeah, hit me up if you have any feedback.